All right, so we're going to analyze and make up this graph of this rational function. So step number 1, factor the numerator and denominator of the function. So x squared plus 4, I can't factor that. It is not x plus 2 times x plus 2. That would equal x squared plus 4x plus 4. So don't make that mistake. The numerator there is not factorable. So that's going to stay x squared plus 4. Now the denominator, I'm going to look at it as being x squared squared minus 1. And then I see that it's the difference of two perfect squares. And the difference of two perfect squares, so my numerator again, x squared plus 4. My denominator now is x squared plus 1 times x squared minus 1. Now, x squared plus 1 is not factorable. But x squared minus 1 is factorable again. That can be x plus 1, x minus 1. So, factoring out this thing completely gives me x squared plus 4 divided by x squared plus 1, x minus 1, x plus 1. So now I can determine the domain. And the domain is going to be whatever makes the denominator 0. So I can see here that 1 will make the denominator 0, and negative 1 will make the denominator 0. And this piece right here, not solvable. Nothing will make it equal to 0. So if I had x squared plus 1 equals 0, that will give me x squared equals negative 1. And I can see that if I take the square root of both sides, I'm going to end up with an imaginary number. So there's no number there that's going to make that equal to 0. So my domain on this problem is x cannot be equal to negative 1 or 1. Or if I want to write it in interval notation, I would go negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. That's my domain. Second step, write R in lowest terms. Well, if I'm looking at it here in its most factored form, I don't see anything that I can cross off the top and the bottom. There are no common factors in the numerator and the denominator. So this is the equation, the function, in lowest terms. Step number 3, locate the intercepts of the graph. So I always like to start with the y-intercept, because the y-intercept is where x is equal to 0. So I just come back up to my function, and I will generally like to do this when it's just in its regular form. And I see if I make 0 for x, I'm going to wind up with 4 in the numerator and negative 1 in the denominator. So my y-intercept is going to be the point 0, 4. My y-intercept is 4. For my x-intercept, I have to make, so I'll write this here. For my x-intercept, I make y equal to 0. So I go back to my function, and I think I'll look at it here in lowest terms. And I have this right here. I'm just going to copy it, and I'm going to put it right here. Okay, so there's my function in lowest terms. And I want to find out where that is going to be equal to 0. So I'll set it equal to 0. And what I see here is that if I were to simplify this, I would multiply both sides of the equation by my denominator, so that my denominator would go away. And over here I would have multiplied by x squared plus 1, x minus 1, x plus 1. But it doesn't really matter what I multiply it by, because I'm multiplying it times 0. That's going to be 0. Which just is a long, involved way of telling me that I'm only concerned with my numerator. I want to see, when I have the function in lowest terms, what is going to make my numerator equal to 0. So if I go x squared plus 4 equals 0, I get x squared equals negative 4, and I can see right away, again, I'm going to have an imaginary number. So for my x-intercept, there is none. There is no x-intercept. So that is step number 3. Step number 4, we skip. We're not testing it for symmetry. So step number 5 is I have to locate the vertical asymptotes. So again, I'm going to look at it here in the lowest terms. And if it's in lowest terms, I look at what numbers make my denominator equal to 0. I don't know what that is doing. I'm sorry. And the numbers that are going to make my denominator equal to 0 are still 1 and negative 1. I didn't cross any of them out. If I had crossed any of them out, that wouldn't be a vertical asymptote. It would be a hole. So let's go to our graph now and graph some of the things that we have found. We have found that we are going to have our y-intercept at negative 4. We found that we're not going to have any x-intercepts. And we have found that we are going to have vertical asymptotes at x equals negative 1 and x equals positive 1. So I'm going to draw those in as dotted lines. And I'm going to go x equals negative 1 and x equals 1. I'm going to label them as my vertical asymptotes. So I've gotten through step number 5. I got my vertical asymptote. Now I'm going to go through step number 6. And I have to find the horizontal or oblique asymptote. So I'm going to go back to my original function right here. And I'm going to say, is that proper, improper, or really improper? Well, the highest power of my numerator is 2, and the highest power of my denominator is 4. So the top is smaller than the bottom. This is a proper rational function. And all proper rational functions have an asymptote on the x-axis. All proper rational functions have the asymptote on the x-axis, y equals 0. So now I have my horizontal asymptote. And I need to determine if there are any points at which the graph of R intersects that asymptote. Well, my graph of R is following this function x squared plus 4 x to the 4th minus 1. Let's just write it down here at the bottom. So I have x squared plus 4 over x to the 4th minus 1. That's going to give me the graph of my function. The graph of my asymptote is y equals 0. Is there any place where this is true? Well, we've already determined that. Well, let's just do the work here. I'll multiply this side by x to the 4th minus 1, and this side by x to the 4th minus 1. So that becomes 0, and I'm left with x squared plus 4 equals 0. X squared equals negative 4. So no, there is no place on this graph where it is going to intersect the horizontal asymptote. So step 6, let's write that down. No intercept of the horizontal asymptote. And now I'm ready to go ahead and graph my function on the calculator. So here's my calculator. Oh, that's the, sorry. Oh, pause. So here's my calculator, and I have just written in the function x squared plus 4 divided by x to the 4th minus 1. And I'm going to go zoom 6. It's graphing it. That's what it looks like. Let's take a look at my scaffolding. Here's my scaffolding. I think my scaffolding fits what this graph looks like. I have a branch that goes along this asymptote and then that vertical asymptote. I have a middle piece that's stuck between the force field of the asymptotes and crosses right there at -4. And I have another piece that goes in that section over there. So it looks to me as if my graph matches my scaffolding, and I'm happy as a clown and done with this problem.